Okay, we are asked to graph a parametric equation, find the initial and terminal point, the curve in which it goes, find the Cartesian equation, and compare the Cartesian equation to the parametric equations. For example number 3, we are given that x is equal to 4 sine of t and y is equal to 2 cosine of t, and t is bound between 0 and pi. Basically, we're going to establish what the values for x and y are based on what t is. So we have a lower boundary of 0 and an upper boundary of pi. We simply plug in 0 for both equations, and that yields what the value for x and y are. So when t equals 0, x equals 0, y equals 2. When t equals half pi, x equals 4, y equals 0. And when t equals pi, we get 0, 2. The next step is to graph those points on the graph. The initial point is the lower boundary of t, which occurs at 0, 2. The terminal point is the upper boundary of t, which is pi, which occurs at 0, -2. As we graph our equation, or graph the points, it looks like an ellipse. So now we need to prove or find the Cartesian equation. So whenever we have something like this that looks like an ellipse, we might think to ourselves, x squared plus y squared equals some number. We know that there's some components that go on the bottom for ellipses. Maybe we divide by 4 and that'll give me sine squared plus cosine squared if I divide the other term by 2. So we're guessing that it might be x squared, or I'm sorry, x over 4 squared plus y over 4 squared, or y over 2 squared equals 1. And if we look at the graph, that would probably work. So when we crank through, we find out that that is actually true. And now we compare the Cartesian to the parametric. We notice that the ellipse, based on the parametric, is only for the right half. We verify our results in the graphing calculator, first graphing with the boundary of 0 to pi for t. That worked. Now 0 to 2 pi, we get a full ellipse. Yes, we did it. It's done.